So this will be the third video in our section 3B on matrix basics. And in this video, we're going to solve systems with augmented matrices. And yes, you will need to follow these steps. So we're going to pretend that we're kind of like a computer and we're going to follow the same step every time. So not a lot of decisions to be made, just follow the same steps over and over. So here we go. Elementary row operations. So these are the things we can do. Any two rows in a matrix may be interchanged. This is only done really in the first step. Second, the elements of any row may be multiplied or divided by a non-zero number. The third thing that we can do, the elements of any row may be multiplied by a non-zero number and then added to the corresponding elements in another row to change the looks. By doing any of these things, you change the looks of the matrix, but you do not change the solution to the system. So here are our steps. I'm going to try and put them down here. To solve a system with augmented matrices. 1, first you have to write the system with an augmented matrix. 2, you're going to use row operations to write equivalent matrices. That means they're going to be matrices that look different, but they have the same answer. So these are the steps we're going to go through as we take our matrices through to come up to a solution. We're going to start off with numbers in all the 6 spots. Our first objective is going to be to get a 1 in the top left corner. We don't care what anything else is. All right. Then in order to keep the 1 in there, we're going to next get a 0 in the bottom left corner. So let's go in that order. After we have the 1 and the 0, we can then make a 1, use row operations to come up with a 1 in the middle bottom. And then the last one we're going to come up with is we're going to come up with a 0 in that middle top column. So as we then translate it, if we translated this matrix right here, it's going to be 1x plus 0y is m, some answer. And so that's really x is equal to m. And the second row says 0x plus 1y is k. So that's really y is equal to k. So x is m, y is k, and that's going to be our solution. So next hint, to get a 0, you're going to use linear combinations, which means you're going to multiply the other row and add it and replace the old row. And to get a 1, you can either interchange a row the very first time, or you can divide the row and then replace the old row. Okay, so here we go. Example 3. We're going to first write it with an augmented matrix. So 1, 3, 5, 2, -1, -4. Draw our line and put our brackets around it. All right, so keeping in mind what we want, we first want a 1 in this first spot, and we've got it. So nothing to do there. Then we want to get a 0 where this 2 is. So we'd like a 0 there, and to get a 0, we're going to multiply the other row. So we're going to multiply row 1 by, now I need to multiply it by something that when I add it, I'm going to get a 0. So I'm going to multiply it by -2, and then I'm going to add, comma there, add to row 2, and then put the answer in row 2. All right, so I'm going to do this kind of over here to the side. So multiply row 1 by -2, so that gives me -2, -6, -10. I'm going to add it to row 2, so just as it was, 2, -1, and -4. So I'm going to add it. I'm going to get 0, -7, and -14. So I'm going to take this here, and I'm going to replace row 2. So when I rewrite this, I'm going to have 1, 3, 5. So the first row stays the same. And the second row becomes 0, -7, -14. All right. So we've accomplished step 1 and step 2. We have a 1 on top, a 0 below it. The next thing we want is we want a 1 in the spot where that -7 is. And to get that, we're going to divide row 2 by -7 and then change it. So row 1 still stays the same. So row 1 stays 1, 3, and 5. And then I'm going to divide 0 divided by 7 is 0. -7 divided by -7 is 1. And -14 divided by -7 is 2. One last thing we need to accomplish is to get a 0 in the spot where that 3 is. And to do that, to get a 0, we have to multiply and add. So what we're going to do is multiply row 2, so the second row, by, I've got a 1 there, and I want a -3 in this spot right here. So I'm going to multiply row 2 by -3. I'm going to add it to row 1. So let's see. So I'm going to multiply. So 1, I'm going to keep the same. So 1, 3, 5. And then I'm going to multiply row 2. So 0, -3, -6. So we multiplied it by -3. And we're going to add it. We're going to get 1, 0, -1. And we're going to replace row 1. So that's the one we want to change. So now we'll have here, I'll have row 1, which is 1, 0, -1. And I'm going to copy down row 2, which is 0, 1, 2. So now I've gotten the spot where I want to with 1, 0, 1, 0. And my solution is on that top row, x is -1, and the bottom y is 2. Let's do one more example. Here we go through it again. This time when I write my augmented matrix, you see how the top one's a 4 and the bottom is a 1 in the front here. I think I'm going to write this row right here on top so that I have a 1 to begin with. So I'm going to have 1, -2, 5, 4, 3, and 9. And we now have a 1 in our top spot. So now we want a 0 underneath it in the spot where the 4 is. So I'm going to multiply row 1 by, what do you think? I want to get rid of the 4, so I'm going to multiply it by -4. I'm going to add it to row 2, and I'm going to change row 2. So let's do that. So we're going to multiply row 1 by -4, so it's -4, +8, -4, -20. I'm going to copy over row 2, so 4, 3, 9, and I'm going to add it and get 0, 11, -11. So rewrite. So my top line's actually going to stay the same, and my bottom line's now going to become this right here, 0, 11, -11. All right, so now we're ready to change this 11 into a 1, and it's always easy. We're going to just divide that row. So we're going to divide row 2 by 11. And then replace it. So that's going to give us 1, negative 2, 5, 0 divided by 11 is 0, 11 divided by 11 is 1, and negative 11 divided by 11 is negative 1. All right, so now we're down to the last spot that we need to fill in, and we need a 0 in that spot. So we're going to multiply the other row. So if I want a 0 in this spot, multiply the other row by positive 2. So multiply row 2 by 2 and add it to row 1. And then change row 1. And that will give us this. So that's going to give us, let's see, we're going to multiply row 2 by 2. So that's going to give us a 0, a 2, and a negative 2. We're going to copy over row 1, so 1, negative 2, and 5, and we're going to add it, so it gives us 1, 0, 3. We're going to rewrite. We're going to change that top row into 1, 0, and 3, and the last row remains 0, 1, negative 1. So our solution then is going to be that x is equal to 3 and y is equal to negative 1. One last thing, let me kind of point out on C, when I write those coefficients 2, negative 4, negative 6, and 3, 1, 5, and if I need to get a 1 in this top spot right here, how do you think I'm going to do it? I'm going to divide everything by 2. So divide that top row by 2 so that it becomes 1, negative 2, negative 3, and then 3, 1, 5, and then continue through where you get a 0 here. Probably this is going to change, but you may still need to get a 1 there and a 0 there. But I'm not going to step through those at this time. Perhaps you can give that a try. Why don't you give that a try, and I'll write that final answer up, and you can see how you did. All right, so here's our answer, and you can pause this and kind of take a look at the steps that I did. X is 1 and y is 2.